Okay, sorry, ran out of time there. So we were doing our binomial squares pattern. So we wrote it out here so that we could see both factors. So we took our first term and squared it, and we got 9x squared. We were taking the product of our outer terms, so 3x times 1/2, and we were doubling it. So because we're multiplying by a half and then doubling and taking half canceled, so we got right back to 3x. And then for our last term, we are adding the square of the last term. So we have 0.5 squared, which is 0.25. Again, getting that trinomial answer to our binomial square pattern. And last but not least, a little science connection. So when we're looking at eye color, in humans, the brown eye gene is the capital B, and it's dominant, and the blue eye gene, the lowercase b, is recessive. This means that humans whose eyes are genes capital B, or capital B, or little b, capital B, have brown eyes, and those with lowercase b have blue eyes because they have both recessive genes. So the Punnett square at the right shows the results of eye colors for children of parents who have one brown gene and one blue eye gene. So here's the mom with a brown eye and a blue eye gene, and here's the dad with a brown eye gene and a blue eye gene. So we get brown brown, we get brown blue, we get blue brown, and we get blue blue. If we need to write a polynomial that models the possible gene combinations of a child, then we can take these products and we can add them together. Okay, so as we look at our combinations, we have brown brown plus brown blue plus blue brown plus blue blue. So brown brown and blue blue are the only two like it, no like terms. But I have a brown blue and a blue brown. Remember, we can multiply in any order, so these are like terms. So I can combine those. So I have brown brown plus 2 brown blue plus blue blue. And we recognize this trinomial as being the square of our first and double the product of our first and last plus the square of our last. So we could simplify this using our special products. We could simplify this to our binomial square. So I could do brown plus blue, that whole quantity squared. If we're looking at what percent of possible gene combinations results in a child with blue eyes, well, we have 4 possible outcomes, and 1 out of the 4 yields blue eyes. So we would say 1/4 or 25%. Now, as you get started on your homework, what you are going to have to look at is you are going to have to determine whether you are looking at a difference of 2 squares, or if you are looking at the binomial squares pattern. So you are going to have to just get familiar with what those look like in their factored form and in their simplified form as a trinomial or binomial.